So now let's do the next problem. Find the inverse Laplace transform of x of s is equal to 1 plus e raised to minus 2s by s square into s plus 1. Okay. So here one of the main difference in this question and the previous question is that here there is an exponential function e raised to minus 2s. Okay. Like I said in the previous video, if you see an exponential function e raised to minus 2s, if you see any exponential function in the s domain, this means nothing but the time shifting property, right? This is nothing but applying time shift in the time domain. That's all. Then do this problem as usual in the previous, like we do it in the previous manner. Okay. So here I can write the question as, here I can say that x of s is equal to, now let me separate these two terms. This is nothing but 1 by s square into s plus 1 plus e raised to minus 2s by s square into s plus 1. Okay. So now, which means that in order to find the Laplace inverse, you have to first find the inverse of this, then you have to first find the inverse of this. Then your answer will be complete. Okay. So first let's find the Laplace inverse of this. Okay. Let's find the Laplace inverse of the first term. The Laplace inverse of the first term, that is Laplace inverse of 1 by s square into s plus 1. Okay, let's find the answer for this. Okay, so this can be written as, so here this is nothing but here there are three factors or three poles, right? That is here the different, that means there are two distinct poles. The two distinct poles are s square and s plus 1. So but this s square is repeating, this distinct pole is repeating, so it will, so you have to write s and you have to write s square. So therefore there are three poles, that is s square and s plus 1. So if I am going to factorize this, the factorization will be like a by s plus b by s square plus c by s plus 1. Okay, because this pole over here s is equal to 0, this pole over here repeats twice, so you have to write it 2 times in increasing power. Okay, so now what you go to do is you go to find the value of a, b and c. So here it is very easy to find the value of b and c because both b and c has the complete factors. A is the one that is incomplete. Okay, so here you can find the value of b and c directly. So let's find the value of c first. Okay, c. So c is equal to, okay, so here the denominator of c is s plus 1. So remove s plus 1 from here. So it will become 1 by s square, and then substitute the value of s as s plus 1 is equal to 0. So substitute the value of s as s is equal to minus 1. You will get the answer as, here s is equal to 1 minus 1 the whole square is 1, so the value of c is 1. Okay, now next, likewise I can also find the value of b because b also has the complete factor, just like your denominator, b also has the complete factor. So the value of b is, here remove s square from here, so the remaining term will be 1 by s plus 1, right? And then substitute the value of s as s is equal to 0. You will get b also equal to 1. Okay, so now you are going to find the value of a. All right, so to find the value of a, you cannot apply this method because the denominator of a is incomplete, right? It is having only one factor, s. It should be supposed to be, here it is s square, but here it is s. Okay, but the thing is that a and b are related to each other. The equation for a and b are related to each other, right? Just simply apply the differentiation, and the difference between the power is 1. Here the power is 1, here the power is 2. So the difference between the two powers of s is 1. So this is nothing but 1 by 1 factorial into, so now differentiate this once, just once. So you will get over here as minus 1 by s plus 1 the whole square. Okay, then substitute the value of s is equal to 0, right? So you will get the answer as 1 by 1 factorial is 1 minus 1 by 0 plus 1. So the value of a is minus 1. Okay, so therefore I can say that 1 by s square into s plus 1 can be written as A, the value of A is minus 1, so minus 1 by S, plus the value of B is 1, so 1 by S square, and the value of C is also 1, so 1 by S plus 1. Okay. So now to find the Laplace inverse of the first term, simply find the Laplace inverse of these three terms. Finished. Okay. So that means the Laplace inverse of, which means the Laplace inverse of 1 by S square into S plus 1, okay, is equal to the Laplace inverse of minus 1. You can take minus 1 common, minus 1 outside, okay. Laplace inverse of minus 1 plus minus 1 by S plus the Laplace inverse of 1 by S square plus the Laplace inverse of 1 by S plus 1. Okay. So this, the Laplace of, you know the Laplace of u of t, right? The Laplace of u of t is equal to 1 by S, right? The Laplace of u of t is 1 by S, and also the Laplace of t into u of t, right? The Laplace of t into u of t is equal to 1 by S square. So this is nothing but minus u of t. This is nothing but plus t into u of t, okay, plus the Laplace inverse of this is 1 by S plus a, which is nothing but e raised to minus 80. So this is e raised to minus t u of t, right? So we found the Laplace inverse of the first term. Okay. Now I'm going to find the Laplace inverse of the second term. That is, I'm going to find the Laplace inverse of e raised to minus 2s by s square into s plus 1. Okay. Okay. Let me write this in this format just to make you understand. Laplace inverse of e raised to minus 2s into 1 by s square into s plus 1. Okay. So now I need to find the Laplace inverse of this. Okay. So you already know that if you are seeing the exponential function S domain, this means nothing but the time shift in the time domain. That means you are going to just need to apply, all you need to do is simply apply the time shifting theorem, right? So what's the time shifting theorem says? That we know that the Laplace transform of x of t minus a, okay, is shifted by minus a seconds. The Laplace transform of x of t minus a is nothing but e raised to minus as into x of s. This is the time, this is the called as the time shifting property, right? The Laplace of x of t minus a is equal to e raised to minus as into x of s, right? Or in other words, I can also, if I want to put this Laplace in this side, so x of t minus a is equal to the Laplace inverse of the Laplace transform of e raised to minus as into x of s. So if you see this exponential function, just it's very easy. Simply assume that you are going to apply a time shift. Time shift means replace every t with t minus a. That's all. Okay. So here, if you can see, this is my e raised to minus as, right? E raised to minus 2s. E raised to minus 2s. Okay. And here my x of s is 1 by s square by s plus 1. 1 by s square into s plus 1. So this is my x of s, and this is e raised to minus as. So what I need to do is simply find the Laplace inverse of this. Find the Laplace inverse of this and then replace every t with t minus a. Simply replace every t with t minus a. Here the value of a is 2. So replace every t with t minus 2. That's all. Okay. So fortunately we have already found the Laplace inverse of this, right? That's what is given over here. The Laplace inverse of this is already given over here, right? So that means, so in other words, the Laplace inverse of e raised to minus 2s of 1 by s square into s plus 1 is nothing but, here instead of minus u of t, replaces t with t minus a or t minus 2. So it becomes minus u of t minus 2 plus this t we replace with t minus 2. So it will be plus t minus 2 into u of, this is replace this t with t minus 2. Wherever you see t, replace it with t minus 2. That is called as time shifting theorem. Plus here also e raised to minus t. So it will become e raised to minus of t minus 2 into u of t minus 2. See? So now I found the Laplace inverse of the first term, and I have now found the Laplace inverse of the second term. So therefore my final answer is, so according to this, my final answer is the Laplace inverse of this plus the Laplace inverse of this. So simply add these two answers. That is my final answer. So therefore x of t is equal to minus u of t plus t into u of t plus e raised to minus t u of t, okay, minus u of t minus 2 plus t minus 2 into u of t minus 2 plus e raised to, here I can make this into minus e raised to minus t plus 2, okay, u of t minus 2. Okay, I can write this in this format. So this is my, I can make this as my final answer. Okay.